$31 joined. Please tell them, CR. They should join the class. $31 joined till now. Why they are doing like this? Why they have kept me on waiting? $33 joined. 6 more remaining to join the class. So we start here. So we start the teaching now.
Yes, sir.
Where are the 6 more students? Where are they?
I've already informed. I don't know, so why they are not.
Why they are not joining? 6 plus 3, 34. 30, what is the strength of your division?
39, sir.
39. Then 34 plus 5. 5 more should join the class. Okay, tell them. So we'll start the today's lecture. Now see, all these things we have seen already. That is all the things we have seen, all the things we have seen, we have seen state, right hand thumb rule and all these things, types of induced EMF, methods of the induced EMFs, then state and explain Faraday's laws of electromagnetic induction, 2 laws, its explanation with a diagram. Already I have circulated these notes to you. State and explain the Lenz's law. Yesterday I have told you about the Lenz's law. Then a statement of the Lenz's law. State means give the statement of the Lenz's law for 2 marks, and then explanation is with the diagram is for 3 marks. Total is 5 marks. Then statically induced EMF. That is it is electromagnet statically induced EMF. There is a change of EMF. That is, there is a change of flux by change of current. Here is no movement in any part, that is in the magnet or in the coil. Here we are keeping there is no motion. We are changing the value of the flux by change of current, and due to the change of flux by change of current and EMF is induced, that induced EMF is called as statically induced EMF. Okay, that's why what is the definition of the statically induced EMF written over here? When magnetic field linked with the coil changes by change of current, this is called as electromagnet, and EMF is induced in the coil is called as statically induced EMF. There are 2 types of statically induced EMF, self-induced EMF and mutually induced EMF. The example of the mutual induced EMF is transformer and induction motor. The example of the self-induced EMF and mutually induced EMF is transformer, then induction motors. That is, these are the examples over there. Then what is the question over here? Explain the self-induced EMF and define its coefficient. Now, what is the distribution of the mark? Diagram is 1 mark, 2 marks, 2 marks for the explanation, and 2 marks for the definition of its coefficient. 2 marks for the definition of the coefficient, and 1 mark for the diagram, and 2 marks for the explanation, and 2 marks for the definition of its coefficient. It is called as self-inductance. Define its coefficient, it is called as self-inductance. So what is a diagram over here? This is a diagram over here. Now it is a solenoid. Now you have applied over here the DC supply battery. Then to change the value of the current, we have connected over here one rheostat, variable resistance. Now this is a terminal 1 of the coil, and this is a terminal 2 of the coil. Now see, current enters from the terminal 1. When current enters from the terminal 1, the direction of the current in the coil is upward. And when current enters from the terminal 2, the direction of the current in the coil is downward in the front side. Because backside we cannot see the diagram. We cannot see the coil, backside coil. We are taking the direction of the current in the front side of the coil. Okay. Now when current enters over here, then see the magnetic field lines is like this, anti-clockwise here like this. Okay, according to the direction of the current, the magnetic field is generating over here. Then what happened over here? Now see, according to statical induced EMF, there is a change of flux by change of current. You can decrease the value of the resistance. Then what happened over here? There will be a increase in the current. There will be the increase in the current, and due to increase of the current, then there will be increase in the flux. Meaning is that there will be change of flux. Initially, if the flux is phi1, then after changing the current, then flux increases phi1 to phi2. Then there will be change of flux phi1 to phi2 minus phi1. Due to that change of flux, the EMF is induced in the coil. The EMF is induced in the coil, and that induced EMF is called as self-induced EMF, because there will be a change of flux due to the change of current in own coil, and EMF is induced in own coil of the turns. And what is the direction of that induced EMF? The direction of that induced EMF is in opposite direction of the supply voltage according to Lenz's law. That's why the self-induced EMF is called as back EMF, because it is in opposite direction of the supply voltage or supply current. If supply current is clockwise, then the direction of the induced EMF is anti-clockwise. That's why it is in opposite direction. That's why the self-induced EMF is called as back EMF. Self-induced EMF is called as back EMF. It is the induced EMF in own coil. The current in own coil, increase of current in own coil, there is a change of flux due to the own coil current. Therefore, induced EMF in the own coil. That's why that induced EMF is called as self-induced EMF. Okay, there is a rate of change of that is, see, why there is a change of flux. There is a change of flux due to change of current. So I can write we know the formula over here, that is the, see here, induced EMF is equal to, we know that is minus, second formula, minus n d phi by dt, rate of change of flux. Rate of change of flux, or I can write here, the induced EMF is directly proportional to the rate of change of flux. But this rate of change of flux is due to the rate of change of current. So I can write here, the induced EMF is directly proportional to di by dt, rate of change of current. Why there is a change of flux? Due to rate of change of current. So self-induced EMF formula, the induced EMF, self-induced EMF, you can see here, EL, self-induced EMF is a directly proportional rate of change of current. If I remove the proportional sign, then I will take the constant of proportionality, self-induced EMF, or you can take it as ES, self-induced EMF is equal to minus n for the direction, back EMF, L into di by dt. L into di by dt, where L is called as constant of proportionality, and it is known as the coefficient of the self-induced EMF, or it is known as the self-inductance, and unit of this self-inductance is the Henry. It is called as inductor also. it is inductor, and therefore the coil is shown by the inductor letter L. The coil is shown by the inductor letter L. So this is my inductor L. Okay, it is a constant of proportionality, and it is a coefficient of self-induced EMF. So it is called a self-inductance or inductor. Unit of the self-inductance or inductor is Henry. So there is a rate of change of flux due to the rate of change of current. That's why I can write the self-induced EMF is directly proportional to rate of change of current. Therefore, self-induced EMF is equal to minus L di by dt. So you draw the diagram, write the explanation of the self-induced EMF, and then write the definition of L, self-inductance. Clear? I mean, okay, clear? Clear? Look here now. Here, M is the magnetic field lines, flux. R is variable resistance, rheostat. N is the number of turns of the coil. Current is flowing in the coil. Now, explanation of this written here. The EMF induced in a coil due to change of flux produced by it, linking with its own turns, is called a self-induced EMF. Okay, due to change of flux, its own turn, and this change of flux is due to change of current in own turns or own coil. Consider, see, this is explanation of the diagram. Consider a coil having n turns as shown in figure. When switch S is closed and current I flows through the coil, it produces the flux phi, which is also links with its own turns. If current flowing through the coil is changed by changing the value of variable resistance R, it changes the flux linking with the coil, and hence EMF is induced in the coil. This is explanation of the diagram. Since the rate of change of linked flux with the coil depends upon the rate of change of current in the coil, therefore magnitude of the self-induced EMF is directly proportional to the rate of change of current in the coil. Magnitude of the self-induced EMF is directly proportional to the rate of change of current in the coil, and its direction is in opposite direction of the supply voltage. That's why it is called as back EMF. It is called as back EMF because according to Lenz's law, its direction is opposite to the supply voltage. That's why it is called as back EMF. So I can write what is the statement written over here. Write these statements in the formula. E is a direct proportional to di by dt. E is equal to minus L di by dt. Minus in for direction of the EMF according to Lenz's law. And where L is called a self-inductance or coefficient of self-induced EMF or inductor, and unit is Henry. Unit is Henry. This is what the explanation of this diagram, and this is the formula of the self-induced EMF. Actually, induced EMF is due to the rate of change of flux. I have written here. Induced EMF is due to the rate of change of flux minus N d phi by dt. But this rate of change of flux is due to the rate of change of current. So I can write this formula. E is equal to minus L di by dt. Minus L di by dt. Then this is also E, this is also E, left hand side, induced EMF same. So I can equate these two. L di by dt, L di by dt is equal to minus N d phi by dt. Minus N d phi by dt. Look here now, derivation we are solving. This dt get cancelled. L di is equal to minus L di is equal to minus N d phi. Minus N also get cancelled. Then L di is equal to N d phi. So N take integration. L di is equal to N d phi. N d phi, take integration of N d phi. So di integration is I, so Li, and d phi integration is phi and phi. So Li is equal to N phi. So I get the formula here. L is equal to N phi by I. This is the first formula of the self-inductance. N phi by I. How I get this formula? Look here. L is equal to N phi by I. The N phi is called as flux linkages with the coil. Linked flux with the coil. It is N phi, number of turns of the coil, and flux. The product of number of turns of the coil and flux is called as flux linkages. Divided by current. Flux linkages divided by current is called as self-inductance. It is the first formula of the self-inductance. It is the first formula of the self-inductance, because we know E is equal to minus N d phi by dt. We know E is equal to minus L d by dt. So left hand side is equal. Then keep the right hand side is equal. Solve it, integrate it. Then you will get the L is equal to minus N. L is equal to N phi by I. L is equal to N phi by I. L is equal to N phi by I. You will get, and they will ask the numericals on this. This is the first formula. So what is here? The diagram written over here. So what is this? This is the explanation of this diagram. Okay, this explanation. Draw the diagram. Draw the diagram. Give the explanation of the diagram. Okay, like this solenoid diagram. Then explanation of this diagram, formula. Then we want to write the definition. L is called a self-inductance or coefficient of self-induced EMF. You can write here one thing. It is called as back EMF. I have not written the why it is called as back EMF. You write, note down. According to Lenz's law, the direction of the self-induced EMF is in opposite direction of the supply voltage or supply current. That's why this self-induced EMF is called as back EMF. Please note down. I have not mentioned over here why it is called as back EMF. Now you write here, the direction of the induced EMF, self-induced EMF, is in opposite direction of the supply current according to Lenz's law or supply voltage. That's why this induced EMF is called as back EMF. This induced EMF is called as back EMF. लिखा आप लोगों ने? CR, please ये लिखो थोड़ा वहां पर. कहाँ लिख के रखेंगे और इसके ऊपर कुछ. Why it is called as back EMF? इसमें मेंशन नहीं किया है. The direction of the induced EMF, self-induced EMF, is in opposite direction of the supply voltage or supply current. देखो ये supply current इस direction में है clockwise, तो self-induced EMF is in anti-clockwise. Self-induced EMF किस direction में रहेगा? Anti-clockwise. So ES, I will draw here. ES, self-induced EMF, ES is in this direction, and supply current is in this direction. That's why it is in opposite direction of the supply current or supply voltage. That's why this is called a back EMF. Now, due to the effect of back EMF in the coil, if you are decreasing the resistance, then current is increasing. Then what is the increase of current? Suddenly will not enter in the coil. आपका करंट इंक्रीज हो गया है, लेकिन सडनली कॉइल में नहीं जा रहा है, बिकॉज ये बैक ईएमएफ इज इन अपोजिट डायरेक्शन ऑफ द सप्लाई करंट. जब तक बैक ईएमएफ का इफेक्ट कॉइल के अंदर रहेगा, तब तक आपका नया करंट एंटर नहीं करेगा. सी, you are changing the value of resistance, you are increasing the current. Now this increase, suppose 2 ampere current is flowing in the coil. Now I'm decreasing the resistance. Then next current is 6 ampere. 2 ampere to 6 ampere, that is a new current. This 6 ampere current, new current, will not enter suddenly in the coil. Why? Because there is a back EMF, there is a self-induced EMF effect in the coil, which is in opposite direction of the supply current. That's why the 6 ampere current will not enter suddenly. It will take some time to enter the new current in the coil. जब तक इसका इफेक्ट कम नहीं होता है, बैक ईएमएफ का इफेक्ट कम नहीं होगा, तब तक नया करंट एंटर नहीं करेगा. बैक ईएमएफ का इफेक्ट जब तक कम नहीं होगा, तब तक नया करंट एंटर नहीं करेगा. मींस the new current will get opposed by the self-induced EMF. When the self-induced EMF effect will get nullified, when it will get vanishes, then new current enters in the coil. This is the property, and this is the property of the coil. This property of the coil is called a self-inductance or inductor. So what is the definition of the self-inductance? What is the definition? Define its coefficient. What is the meaning of constant of proportionality over here? Define its coefficient, 2 marks definition. So what is a self-inductance? It is a property of the coil to oppose the change of current in the coil. It is opposing the change of current in the coil. इस coil के अंदर जो नया current आ रहा है उसको oppose कर रहा है. कौन कर रहा है oppose? Coil कर रहा है. वही coil is opposing this current because coil के अंदर पहले से ही self-induced EMF मौजूद है. Because there is a presence of the self-induced EMF in the coil, that's why the new current is not entering in the coil. This property of the coil is called as self-inductance or inductor. Clear? So what is the definition here written here? See, what is the basic definition of the self-inductance? The property of the coil due to which it opposes the change of current flowing through it itself is called a self-inductance or inductance of the coil. This property is attained by the coil due to the self-induced EMF in the coil. This property is attained by the coil due to the self-induced EMF present in the coil. Due to the self-induced EMF present in the coil. जब तक सेल्फ इंड्यूस्ड EMF का इफेक्ट रहेगा कॉइल के अंदर तब तक न्यू करंट एंटर नहीं करेगा. दिस प्रॉपर्टी इज कॉल्ड एज न्यू करंट एंटर नहीं करेगा मींस द कॉइल इज अपोजिंग टू द करंट टू फ्लो इन द कॉइल which is opposing that new current. So this property, the property of the coil due to which it opposes the change of current flowing through the coil is called a self-inductance or inductor of the coil. This property is attained due to the self-induced EMF in the coil. Clear? Boys, are you with me? Clear? मेरे से बात करो. हेलो, आप लोग साथ में हो? हेलो boys, are you hearing me properly?
Yes, sir.
Definition समझ में आया?
Yes, sir.
डायग्राम समझ में आया? सेल्फ इंड्यूस्ड EMF का
Yes, sir.
सोलेनॉइड का डायग्राम है, उस डायग्राम का एक्सप्लेनेशन समझ में आया कि
Yes,
नहीं
sir.
आया?
Understood.
CR, you are the leader in your division. सबको पूछो, स्टूडेंट्स के और मेरे बीच में आप मिडिल, आप यू आर द कोऑर्डिनेटर बिटवीन मी एंड योर डिवीजन. मेरा मैसेज पास करो, सबको पूछो, समझ में आया क्या? कुछ डाउट है क्या? क्योंकि उनको डर लग रहा है मेरे से बात करने को, तो आप पूछिएगा उनको. Boys, what is the definition of the self-inductance or inductor L? It is a property of the coil. It is a property of that coil to oppose the change of current in the coil due to the presence of the self-induced EMF in the coil. This property is called as self-inductance or inductor. आया क्या ध्यान में? coil की property means इंडक्टर. देखो, कोई भी कॉइल हम किस लेटर से दिखाते हैं बॉयज? सी आई एम यूजिंग बोथ लैंग्वेजेस फॉर अंडरस्टैंडिंग पर्पस. ये मेरा कॉइल है, ये कॉइल मैं एल लेटर से डिफाइन कर रहा हूं. कॉइल हम क्या कर रहे हैं? एल लेटर से, हम इंडक्टर एल लेटर से दिखाते हैं. तो एल का मीनिंग क्या है? ये आप है, समझो, ये सीआर है क्लास का. ये भी आपकी तरह ही है, लेकिन इसको हमने नाम दिया है. सो वो नाम इसका प्रॉपर्टी है. So we are showing this coil by this L later. So L का meaning क्या है? It is a property of this coil to oppose the change of current in the coil. Why this opposition occurred over here? Due to the presence of the self-induced EMF in the coil, and this self-induced EMF is in the opposite direction of the supply current. So new current enter ही नहीं करेगा इस coil के अंदर जब तक इसका इफेक्ट है opposite direction में. This property of the coil is called as self coefficient of the self-induced EMF or self-inductance. Clear this point? Clear this point? Definition of the 2 marks. Boys.
Yes, sir.
यार समझ में आया क्या definition? Boys. Understood the definition? Boys.
Yes, sir.
जब तक आप नहीं बोलेंगे तब तक मैं सर्कल राउंड करते रहूंगा. बोलो बोलो yes or no. सब बोलो yes or no. Other boys also tell me yes or no. Understood the definition or not? कोई बता नहीं रहा है.
Yes,
They are
sir.
not, they are not responding. Okay, so see, what is the question? See, I have made the notes by putting the question over there. I don't want to fail anybody in the subject because till now the 100% result up till now of this subject. देखो, explain the self-induced EMF and define its coefficient. Distribution of the mark, diagram 1 mark, 2 marks explanation of this diagram and formula, and 2 marks for the definition of the its coefficient, inductor definition, self-inductance definition. Clear? So then after that we want to see the formulas of the self-inductance. After that we want to see the formulas of the self-inductance, that is L. So first formula, L is equal to N phi by I. ये कैसे आया समझ में आया formula? L is equal to N phi by I, boys. ये कैसे आया? Can you prove this formula? Unit is Henry. L is equal to N phi by I. What is N phi? Number of turns and flux. Product of number of turns and flux is called as flux linkages. So it is a ratio of flux linkages to current in the coil is called as self-inductance as well. That is the second definition. But what is the basic definition? It is a property of the coil to oppose the change of current in that coil is called as self-inductance. Clear? Basic definition. Then formula,
Yes,
formula
sir.
का definition क्या है? Formula का definition ये कैसे आया रे? How you got this? L is equal to N phi by I. Just I proved this. किया कि नहीं किया? क्या किया?
Yes, sir.
See, we know the definition of self-induced. We know definition of induced EMF. Rate of change of flux. Clear? Clear? Then we know the self-induced. This rate of change of flux is depends upon rate of change of current. So I can write the definition for self-induced EMF, 2 formulas. That is self-induced EMF is equal to minus N d phi by dt and self-induced EMF is equal to minus L di by dt. Left hand side equal है, right hand side equal हो जाएगा. So N d phi by dt is equal to minus L di by dt. The dt get cancelled. Then minus L integration of di, taking integration both sides, is equal to minus N integration of d phi. किधर गया रे? अरे किधर गया रे? अरे किधर गया रे? हाँ, इंटीग्रेशन ऑफ डी फाइ. So what is di integration is I minus n get cancel. अरे ऐसा क्यों हो रहा है रे boys? अरे हाँ, Li is equal to n phi. So L is equal to n phi is called as number of turns and flux. N phi divided by I. Clear? Clear? And what is unit? Henry is the unit for the L, shown by the capital letter H. Clear boys? L is equal to n phi by I. कैसे आया समझ में? Because
Yes, sir.
numericals on this. It is the first formula of the self-inductance or inductor or coefficient of self-induced EMF. Unit is Henry. Clear? First formula. Okay. Then second formula from the definition. What is the definition? Self-induced EMF is equal to minus L di by dt. What is di by dt, boys? आराम से पढ़ने का. What is the di by dt? Rate of change of current. di by dt is called as rate of change of current. d phi by dt is called as rate of change of flux. So minus L is equal to, or L is equal to, direct you can take, L is equal to minus 10 for direction. आप ले सकते हो, नहीं ले सकते, कोई प्रॉब्लम नहीं. L is equal to self-induced EMF divided by rate of change of current, di by dt. This is the second formula of the rate of change of current. This is the second formula of the self-inductance or inductor or coefficient of self-induced EMF. Unit is Henry. Rate of change of current. Okay. ES divided by di by dt from the formula. Now, how to calculate di? How to calculate di, rate of change of current? In the numerical, plus 12 ampere current was reversed. 12 ampere current was reversed in time 10 seconds. If the 12 ampere current was reversed in time 10 seconds. Now, what is meaning of this? 12 ampere current was reversed means, look here. This is a plus 12 ampere current. It is reversed means it goes to minus 12 ampere. Plus 12 ampere current was reversed. Reverse means it goes to minus 12 ampere in 10 seconds. So plus 12 ampere will get reverses to minus 12 ampere. So this time, this is called as a dt, or this is time t, and this is current I. That is on y-axis, on x-axis time t is there, and this time is dt time. And these are 10 seconds. Suppose dt is given, dt is in 10 seconds, then plus 12 ampere current was reversed in 10 seconds. Meaning is this, you draw the diagram. If the numerical is like this, the plus 12 ampere current is reversed in 10 seconds, 10 milliseconds or 10 seconds. Then current is reversed means plus 12 ampere current is reversed means it goes to minus 12 ampere. In 10 seconds, then find di. Di is what? Change of current. DI is what? Change of current. This current minus this current, reverse current. So plus 12 ampere current minus change of current minus sign minus 12 ampere current. So what is the DI? DI is equal to plus 12 minus minus plus 12 plus plus, that is 24 ampere DI. Change of current, this current I1 minus I2. Okay, this is my I1, this is my I2. So change of current is I1 minus I2. I1 is plus 12, I2 is minus 12, and this is a change of current minus sign, I1 minus I2. So I1 minus minus plus 12, therefore plus 12 minus minus plus 12, 12 plus 12, 24 amperes. That is the change of current DI. And DT is 10 seconds. So what is the DI by DT? 24 divided by 10. DI by DT is 24 divided by 10. You have to solve the numerical like this. Clear this point, boys? Hello? If 12 ampere current is reversed in 20 seconds or 10 seconds or 10 milliseconds, so you have to find the DI. DI means 12 ampere current is reverse, means it becomes plus 12 to minus 12. Then find the change of current, plus 12 minus minus 12 minus minus plus. So plus 12 plus 12, that is 24 ampere. Clear? I have taken one example. Hello? 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 Hello, boys? Are you with me?
Yes, sir.
CR? CR? What is the name of the CR? Omi? Om Priyam? CR?
Sir,
What is your
Tushar.
name? Tushar. Okay. Parth Chaturvedi, I got the name. Aryan Pala, I got the name. Nilesh Patil, I got the name. Piyush. Then Qureshi. Ranveer Singh, I got the name. Ritul Singh. Who is Ritul? Ritul? Hello? Ritul, please give the attendance. Ritul, are you hearing me? Boys? सर, क्या आप लोग सीआर ये बात क्यों नहीं कर रहे बाकी के लोग मेरे से? आप लोगों को कुछ बताया गया है कि भाई when the class is going on, please keep the pin drop silence throughout the class, like this told you. But when faculty is asking something, then you have to respond, no? हाँ? Hello?
Yes, sir. Yes, sir.
बाकी लोग respond करो ना, मैं पूछ रहा हूँ तो respond करो. He is Ahad, AHAD 049. I don't know. Are really students attending lecture? Hello, CR?
Yes, sir.
Sub
Yes, sir, we are
attend कर
attending.
रहे हैं. Then
Yes, sir.
why, if I'm taking name of some student, why they are not telling Sarthak Sinha? Is there? Swastik? Sahil?
Yes, sir, I'm there.
Where is the Sarthak Sinha? सब राम भरोसे चल रहे हैं, हाँ? सार्थक सिन्हा किधर रह रहे हो? There is
Yes, sir,
Sarthak.
I'm there.
Is there? Raju, Kumar. Just I'm checking students with me, or just they are logged in and then they have gone to that brokery shop.
No, sir, everyone are with you.
Everyone is with me. Then why they are not responding to me if I'm taking the name?
Yes, sir.
Raju Kumar. Raju Kumar is there? Raju Kumar is there? CRA काम करो, मैं जिसका नाम ले रहा हूं तुम ही बोलो सबको. Yes sir, I am Raju Kumar. Piyush, Sing. I don't
Yes,
know.
sir.
Guys, I don't. Yeah, Piyush. Okay, no problem. Is there any doubt in the how to solve the that is problem, and what is the second formula of the self-induced EMF? Self-inductance, self-inductance, inductor, or coefficient of self-induced EMF. These are the names of L. Every coil we are showing by L, and it is a property. L is the property of the coil to oppose the change of current in the coil due to the effect of the self-induced EMF in the coil. This is called as self-inductance. Clear? 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 Second formula समझ में आया? First formula क्या है रे? L is equal to flux linkages divided by I. Second formula क्या है? L is equal to self-induced EMF divided by dI by dt from the formula. dI by dt. Clear? ES divided by dI by dt. This is the first formula. The second formula, self-induced EMF divided by dI by dt. Okay. Clear? Then third formula we want to calculate. Now see, this is your solenoid diagram. Then flow of current, flux generates, means solenoid becomes magnet, means it becomes magnet due to the production of the MMF. So we know the formula of MMF. Ni is equal to formula of MMF. Ni is equal to phi s. S is a reluctance, is equal to HL. L is the length of the magnetic substance. Then we'll take the help of these two formulas. We will equate these two. Ni is equal to phi s. Ni is equal to phi s. And we know L is equal to N phi by I. N phi by I. So we can calculate the value of phi from this. Phi is equal to Ni by S. From the MMF formula, we can calculate the flux phi. S is the reluctance for the solenoid. Then Ni is equal to phi s. Therefore, phi is equal to Ni by S. Put this value of phi in this equation. Clear? L is equal to N phi by I. Put phi is here. So I will erase this. Then I will take this. Put the phi over here. L is equal to N as it is into phi formula Ni by S. S is called as reluctance. We have replaced this phi by putting the value of phi from the formula of MMF Ni by S into this I. Into, see, we have kept the formula, we have kept the value of phi here in this equation number 1. L is equal to N phi by I into 1 upon I. So this I get cancelled. N into N, N is called as number of turns. N into N is N square. So L is equal to N square by S. This is the third formula. Number of turns square divided by reluctance S. Third formula of the self-inductance, N square by S. Clear this point? कैसे है ध्यान में है? Taken the help of the MMF formula, Ni is equal to phi s. From that you can calculate phi. Phi is equal to N by S. Then we know the first formula of the self-inductance, L is equal to N phi by I. Put value of phi in this equation, and then you will get the third formula of self-inductance, L is N square by S. So what is the third formula? n square by s. So what are the three formulas of L? कौन बताएगा मुझे? CR बताओ, फर्स्ट फार्मूला क्या है? बताओ, बाकी लोग सुनो. Please tell me the first formula of the L. First formula of L is what? N phi by I. Second formula of L, self-induced EMF divided by rate of change of current, di by dt. And third formula of L क्या है? Number of turns square, n square, divided by reluctance. And what is the reluctance formula? S is equal to two formulas. One is Lm, mean length, divided by A mu. A is the area of the cross section, mu is the total permeability, and mu value is mu naught mu r. Clear? Mu value is mu naught mu r. And what is the value of mu naught here? 4.2 10 to the power minus 7. 4.2 10 to the power minus 7 Henry per meter. Clear? आया क्या ध्यान मेरे बॉयज? हेलो हेलो ऑल बॉयज, आया क्या ध्यान में?
Yes, sir.
Yes, sir.
Okay, got the first formula, got the second formula, got the third formula, because they will ask the numerical, 5 marks numerical on these three formulas. Anyone, you can read the numerical, or you read the numerical and see which formula is applicable for that numerical. Which formula is applicable for that numerical? Write that formula and solve the numerical. Compulsory numerical will come for 5 marks in the exam. Clear? Clear? Hello? अरे आप मुझे ये again. Okay, what is your lunch break time?
Yes, sir.
Yeah?
It's clear. Sir. Yes, it's
आप
clear.
लोग बोर
Sir,
हो
from
गए क्या?
12 onwards.
या बोर हो गए आप लोग? कोई प्रॉब्लम, आराम से पढ़ना है. अगर बोर हो रहा है क्योंकि दो तीन बच्चे छोड़ के गए हैं क्लास, क्या करें बोलो?
Network issue.
स्टॉप करो.
हो गया वो.
अच्छा, कंटिन्यू करूं और स्टॉप करूं? देखो इधर 3 फार्मूला लिखे हैं मैंने. n5 by n square by s el divided by di by dt. This is self induced EMF and self inductance. Then what is there? Formula कैसे पूछ सकते हैं क्वेश्चन फार्मूले के ऊपर? Write down the expressions for the self inductance, or derive the equations for the self inductance, or explain the methods for the self inductance. What are the methods or expressions? See, formulas. n square by s. Okay boys, आया ध्यान में? CR, कल का अटेंडेंस आपने मुझे भेजा है क्या?
Actually सर कल लैन एकदम से बंद हो गई थी तो सर अटेंडेंस नहीं ले पाए सर.
तो आज भेजो मुझे व्हाट्सएप पे.
Yes sir.
कल का और आज का मिलके मुझे व्हाट्सएप पे अटेंडेंस भेजो. तो ये समझ में आया? 3 फार्मूला, डायग्राम समझ में आया? सेल्फ इंड्यूस्ड EMF. अभी कल क्या करेंगे नेक्स्ट लेक्चर में? म्यूचुअल इंड्यूस्ड EMF and its coefficient. Mutual induced EMF and its coefficient, and then coefficient of coupling. That was the last point. And then we'll go for the numericals. Clear? आया ध्यान में? Okay?
Sir, all present sir.
Present.
Yes
So एक काम करो ना, मुझे
Yes,
भेजो. अभी लाइट चला गया, स्क्रीन का लाइट चला गया. So I will leave the lecture. अभी आपका लंच ब्रेक है 12 to 1. Boys?
Yes,
Hello?
thank you.
अभी ओके नो प्रॉब्लम. अभी आप लोग जा सकते हो. जस्ट अभी स्क्रीन का लाइट चला गया है. जब लाइट आएगा देन आई
Yes.
विल स्टॉप द लेक्चर, आई विल लीव द लेक्चर। ओके, अभी आप लोग जा सकते हो लंच के लिए।
Yes, sir. Yes, sir.
अभी जो मैंने पढ़ा है उसमें कुछ डाउट है? अगर है तो कभी भी मुझे फोन पे पूछिएगा, कोई प्रॉब्लम नहीं। ओके, सो आई एम स्टॉपिंग द
Yes,
लेक्चर।
sir. Thank you, sir.